Hi. Like most Twitter employees, I'm currently locked out of my office. So, welcome to my home. Last week, there was this interesting tweet made by Elon Musk, which seems to show an architecture diagram of something about Twitter. Seeing this image, the architecture nerd inside me just jumped. In this video, I'm going to break down what this diagram is, what it's trying to show, and we might learn some things about software architecture on the way. But before that, this is kind of a poorly drawn whiteboard diagram. It's a little hard to see, there's a lot of reflections. So I decided to take some creative liberty here and remade this diagram in one of my favorite tools, Excalidraw. Oh, a little bit more. There we go. So in this video, we are going to really do three things. The first is that we are going to analyze this diagram, not the architecture behind it, but the diagram in its entirety. What is this diagram really trying to depict? Does it do a good job of it? Is it a good diagram? How do we get the most information out of this diagram? The second thing is then diving deep into this architecture of which part of the Twitter system it represents, what it's doing, how it delivers value to the user. And finally, we are going to try to learn some things out of this. So let's jump in. The first thing that you would want to look for whenever you see an architecture diagram like this is for some sort of a caption or title. That usually is the best way to figure out what this diagram is about. Here we don't have a big flashy caption. Instead, we have this caption saying read path. It's pretty straightforward. It's trying to show what happens when you first log into Twitter, how the application reads data from its system to render a timeline or a home feed for you. The second thing that you would want to look for is some sort of a legend or a notation reference of what the boxes and what the arrows would mean. Now, most of the time, it's pretty straightforward. The boxes represent some sort of a service, whether that be a physical microservice or a smaller module inside a bigger service. And the arrows usually mean some flow of information or data. However, we also have this piece of reference here that says that dashed arrows are next-gen systems. So based on that, we can probably infer that the solid arrows are how the connections exist right now, and the dashed arrows are the connections that they would want to exist in their next-gen system. This also gives us one other piece of insight, which is that they are probably migrating away from a current system to a next-gen system, maybe in hopes of better performance or better maintainability in the long term, whatever. Those reasons are not specified in this diagram, but we can pretty clearly see that there is a current or existing system and there is a next-gen system, and they're in the process of migrating over. So based on those two pieces of information, the caption read path and the next-gen system arrows, we can come to a conclusion that there are two questions that this diagram is supposed to answer. The first one, what does the first visit call graph look like? And the second question is, what should the first visit call graph look like? Now, first visit call graph, it's the same thing that I mentioned before. It's what happens in the system when you first open Twitter and how the application tries to render your home page. The first question of what it looks like right now is the current system, and the second question describes the next gen system. Now, in this diagram, we see kind of a mesh of both. So to make better sense of it, we're going to split this diagram into two separate parts that answer those two questions individually. Here is the same diagram, but I've removed all the next gen system lines and everything that it connected to, so we only see what the current existing system looks like. Now, we don't have a lot of information here, but there are some interesting things going on. First of all, you might notice this big, huge blob called the timeline mixer. Now, the responsibility of the mixer is to collect a bunch of different information from different services. For example, the People Discovery service probably gets at a list of accounts that you might be interested in following. Ad Mixer, pretty straightforward, provide ads. Onboarding service, I'm not too sure about that. And then we have Timeline Scorer and Timeline Service. We don't have a lot of information on exactly what these are doing. My guess is that Timeline Service is responsible for fetching some list of tweets, and then Timeline Scorer would be responsible for taking those tweets, running it through some sort of a machine learning model or prediction model, and coming up with scores of how relevant are these tweets to you so that they can be shown on your homepage. And finally, the timeline mixer will mix all of this information up into kind of a random looking timeline so that you don't have a bunch of tweets about the same thing together. They're all mixed up nicely for you. We can also see that it's adding more information like the conversation module, it's adding pagination, and it's a data logging, it's removing duplication of tweets and things like that. This arrow here has a label called Thrift RPC. That probably means that all of these communications are happening through Thrift RPC as well. Now, if you don't know much about Twitter infrastructure, Thrift is an RPC mechanism that I'm not sure if they developed it in-house or if it existed before Twitter, but Thrift RPC is what Twitter uses quite extensively for all internal remote procedure calls. They don't use gRPC because I think gRPC was not around when they were building this system, so they picked Thrift instead. They also use something called Finagle for networking all of their services together. Finagle allows any kind of RPC protocol on top of it, so Thrift or HTTP or gRPC or any other RPC protocol that you might want to use. You can use that on top of the Finagle networking system. And then we get to this part here, which is how all of this data gets served to the front end directly. Now, obviously, we have their older TLS API, which they're deprecating in favor of the new GraphQL API. The GraphQL API here uses another technology called Strato or StratoQL. StratoQL is pretty similar to GraphQL, but the purpose of StratoQL is much more different. GraphQL is supposed to be used for client-server communications like we have here. So for public APIs. StratoQL, on the other hand, Twitter also calls it the domain-specific language for microservices. That sounds like something that you would extensively use on the back end and not quite on the front end. StratoQL is written in Scala, I believe, and it has pretty tight integration with the Thrift RPC system. So we can see here that the GraphQL server uses Strato to communicate with the timeline mixer. And then the timeline mixer, like I mentioned earlier, combines data from a bunch of different services and serves them back to the GraphQL API, which can then populate the mobile app or the web app. There's not much else to analyze here. There's not a lot of other information. So let's move on to the more juicy part, the next gen system. Now, similar to the last one, I removed everything that was a part of the current or the legacy system of Twitter. The backbone of this system are the main dotted lines or dashed lines. I don't know if these are dashed or dotted. And here already you'll see that there's a lot more information. There's a lot more going on. Now, it's a lot more going on, not as in it's a more complex architecture than the last one, but it's a more complex and more detailed diagram than the last one. A diagram can never appropriately represent an architecture. I'll talk more about that in the conclusion of this video. But the point is that you can clearly see what the priorities were of the people who were drawing this diagram on the whiteboard on Twitter. They were trying to show what the next gen system looks like a lot more than the old gen or the current system. So let's get into it. Now, straight out the gate, you can see that the TLS API is gone. They marked this as deprecated, so I just decided to remove it from here. The other big thing that you might see here, in the old system, they use the word timeline quite a bit. Here, they have just gotten rid of the word timeline and using the word home instead. Now, renaming choices like these are pretty significant. They're not just about renaming what a service is, but it's more about what the internal shared language of the team is, what they think their products are, how they deliver value to their users. So they are not just changing the name of their services from Timeline Mixer to Home Mixer, they're also changing that terminology in all of their internal communication, maybe even in their business meetings. This also sometimes comes with some sort of organizational changes, but we have no other information about that, so I won't get into that anymore. Now, when an architecture diagram has so much going on like here, it's usually a lot more helpful to go backwards instead of going forwards. So if we start to interpret this diagram starting here, well, we know what the front end and the GraphQL services are, but let's come here and talk about what the home mixer is. The home mixer is something that's fetching data from HomeRanker and a bunch of these other services. What does the HomeRanker do? It makes additional requests, something called candidate fetch, and then something called HomeScorer. What does HomeScorer do? Make additional requests. So if we go in this sequence, we will just run into What does X do? Talks to Y. What does Y do? It talks to Z. Instead, the better way or the easier way to look at these diagrams is to start here. Let me explain why. So we've seen that in this diagram, we only have one-way arrows going from one box to another. But what that really means is that if there's an arrow from A to B, A is actually requesting B for some data, and then at some point B will come back to A with that data. Now, if we had another arrow going from B to some other service, B doesn't own all the data that it will need. It means that when B needs to run some operation or handle some requests, it will need to reach out to some other service to complete its operation. If there are no arrows going outside of B, that means that B has all the data that it will ever need. That can also mean that there is no data to be owned by B. It could be a purely computational service. Think of a service that just does math. You can send it a big complex calculation to solve, and it will parse the entire calculation, figure out what to do, and give you back the results. It doesn't need any data to do it, or it could have some data cached inside. But regardless, that service will own all of its data instead of having to request another service. So if we look at the services in this diagram that don't have any outgoing arrows, they're the easiest to understand. For example, this prediction service here is doing probably some sort of prediction, which means maybe you give it some data set and some criteria for relevancy, and the prediction service will come up with scores or prediction of what elements of those data are relevant. I don't know too much about machine learning, so I'm not going to spend too much time here. I'm going to come to these services here that also don't have any outgoing arrows. These four services here are different databases that Twitter uses. Manhattan is their primary key value data store that is highly distributed and highly scalable. Twitter uses Manhattan to store most of the core data like tweets, users, direct messages, things like that. Gizmoduck, we don't have too much information on, but it's some sort of a service that stores user profiles. Social Graph is pretty straightforward. It's just a graph database that probably connects all the users together. I believe Twitter uses RocksDB for this. And TweetyPie is, again, we really have no information on this. The other three, you can find them online on the internet somewhere. But TweetyPie, we don't really know anything about. And let's now come to these services here. These are what Twitter calls candidate generation services. Now, to understand what a candidate generation service does, we first have to understand what a candidate is. Think about it like this. When a human and Twitter.com really love each other, they interact with each other. And out of that interaction, something is born. Something that, as soon as it's born, is sent off to live in a disk in a large distributed system somewhere. We don't know how it gets there, but we know that it does. Once it reaches there, it sits and gestates and just waits. It waits for the time to come. The time when you log on to Twitter.com. As soon as you open Twitter.com, it comes out of its hibernation and enlists into the early bird program. It has dreams, it has hopes. It has the goal that maybe in a couple more seconds, it will show up on your Twitter homepage and entertain you or enrage you, one of those two. But before it can realize its hopes and aspirations, it must go through some of the most difficult and brutal fitness tests that exist on this planet. No, it's not trial by fire. It's something much worse. It's trial by machine learning models. In summary, a candidate is just something that shows up on your Twitter timeline if it's relevant to you. With that information, we can get back to this architecture here and talk about the candidate generation services of Twitter. These are services that generate different kinds of candidates that would show up on your homepage. For example, Early Bird here is a reverse index that Twitter uses for their tweets. Early Bird also powers their search feature. So whenever you search something on Twitter, it goes to their search engine called Blender, which they've written in Java. And that search engine talks to Early Bird, which is their reverse indexing service. I'm not sure what that means really, but that's how it sources all the tweets to show on your search. And here, Early Bird is used to generate candidate tweets to show up on your timeline. Spaces and communities are pretty straightforward. CR Mixer and UTag, I don't really have any information on. My guess with UTag is that It's either some sort of a geolocation service that finds tweets that are like in your location because they would be more relevant to you, or it could be something for hashtags. So instead of looking through tweets, it looks through hashtags, which again, if they're relevant to you, they're a candidate. And CR Mixer might be something for ads. I'm not sure because we don't see ads anywhere else on this diagram, so that might be it. And finally, up here we have another prediction service. Again, no arrows going out of it, so it's either a purely computational service or it has its own internal data stores. So those were the endpoints of the architecture that is shown in this diagram. Now we can do a much better job of understanding how it all fits together. The protagonist of this story is the home ranker. Now, the home ranker has been given a critical mission, something that the big blue bird really depends on. The mission, should it choose to accept it, now it doesn't really have a choice, it's a bot. Anyways, the mission is to go through the entire Twitterverse and find the things that are the most relevant to you that will be put on your homepage for your entertainment or enragement. That's the job of the home ranker. Now, to achieve this mission, the home ranker first comes down to fetch a list of candidates. To do that, it requires some help of its fellow candidate generation services. So it comes down here, it enlists the help of its services, and then comes up to the fetch function. Now from here, they travel into the realm of machine learning features. But before they can go any further, they first need to get some actual candidates. So they take a turn and go into the land of the deep, dark databases. They enter the distributed disks of Manhattan, turn every piece of magnetic material, and look for every byte. They go through the fast-paced, always moving highway of Memcache, constantly looking for anything that might be even slightly relevant. And they go through some of the darkest forests that Twitter has known, that we won't even know about. But when they come back, they have an army of candidates, thousands, if not hundreds of thousands of candidates that are ready to go to war. The candidates come back to the machine learning feature land and are ready to go through the tests, the trials, and the tribulations. They travel to the very heart of the machine learning feature land, the scoring system. Here, they are met with some of the most difficult challenges that they have ever faced. And, of course, not all of them live through it. There are a lot of casualties. A lot of candidates fall because they were just not good enough. But the ones that don't come back victorious. And they all report back to our protagonist, the home ranker. The home ranker, though, is not satisfied. She thinks that we still have way too many candidates and there's room for improvement. So, the ranker goes to her best friend, the home scorer. The home scorer now has a much different criteria in mind. She is going to put these candidates through some extreme tests that they haven't had before. Through some extreme tests that make the machine learning feature land look like tutorial mode. But before that, she has to do background checks. So when she first hears from Ranker, the first thing that the scorer does is to go back into the land of the deep, dark databases. The scorer is looking for any information that she can find on these candidates, any information at all. If it's a tweet, she wants to know who made this tweet, who's liking this tweet, who's commenting on it, who's quote tweeting it, what other things has this person tweeted, is this thread, what replies exist in this thread, what even is this tweet about, what are the words, how do they fit together, what is the wisdom in this tweet, what is the sentiment, what is the joke, what is the meme. Every piece of background information that exists on these candidates, she will find it. And once she does, she will send these candidates to another prediction service, which is another set of trials and tests that are even more deliberate, even more brutal than the last ones. Most of the candidates that so bravely passed all the tests in the machine learning feature land stand no chance to the tests that the home scorer has in mind, and they all perish, except for the best of the best. those come back with scars, with glory, and with a shine in their eyes, with a sense of satisfaction and victory that they are the best. They are the ones that are going to be the most entertaining on your timeline. The home scorer welcomes them back from their tests, and all those candidates go running back to the ranker, excited, cheerful, and waving their score sheets in the air. The home ranker this time is satisfied. She is confident that she has the best of the Twitterverse for you. The home ranker then reports back to her boss, the home mixer. The home mixer has this nice ordered list of candidates that are going to be on your timeline. But the home mixer is clever. The home mixer knows that we are probably not going to enjoy a perfectly ordered feed of tweets. I don't want to see 6 tweets about tech, and then 7 tweets about gaming, and then 10 tweets about philosophy. I want it to be kind of mixed up. I want to make sure that if there's a person calling Java the best programming language, it is immediately offset by at least 3 cat videos. And I need a Dan Abramov tweet saying that vegetables are tasty before I see any political takes. So the home mixer takes this nicely ordered and ranked set of tweets and mixes them up into this seemingly random looking order. Now, the mixer probably doesn't do it completely randomly. It probably has some sort of an algorithm to figure out the most engaging order of relevancy. For example, the very first 3 tweets that I see, if they are not incredibly relevant to me, I would probably just switch off. So maybe the first 2 or 3 tweets have to be highly relevant, and after that, it can have some randomness to it. But the main point is that the home mixer is responsible for mixing up those candidates into a nicely engaging home feed. Once it's done that, it can refer back to the data stores, all the different databases, and it can hydrate the data. Because all the home mixer receives are the bare identifiers of the candidates, so if the home mixer has to provide that information to our front end here, it needs all the data. Okay, that was a big story. That was a lot of drama. I hope it wasn't too much, but let me quickly go through all of that once again in a more straightforward way. The one thing that I kind of modified in this diagram here is that I made this arrow go in here instead of directly to the candidate generation services. Now, the reason for that is that this fetch did not have any arrows going into it. I'm not exactly sure if there is anything else that is calling fetch. And if this directly connects to the candidate generation services, all it does is that it gets some candidates and it runs through a prediction and it goes back to Mixer. These areas here are never touched. Also, this is called candidate fetch, and there is a box called fetch here. It's kind of in this weird dashed box here. So this area is a little unclear in the diagram of how it's supposed to fit together. So I decided to do that. Now, I might be completely wrong here, and if I am, let me know in the comments. While you're there, please hit subscribe as well. But this makes a little more sense to me, so that's what I'm going with. Once there is a request by some user for the homepage, the home ranker goes to this fetch function, which uses the candidate generation services that we talked about, and then it goes to the databases to get all the data, and then it goes to a prediction service to filter through that data. After that, it goes to the home scorer, which basically does the same thing, but again, Twitter's approach to finding relevant candidates or relevant tweets for your homepage exists in multiple steps. This prediction service here uses some of their most complex and most detailed machine learning models that they have to find the most relevant things for you. However, running those models and running those predictions are also very computationally expensive. They simply cannot practically run those kind of predictions for their entire dataset. Instead, they have their much larger dataset go through a much more simpler prediction. The models that are used here are not as complex as the ones here. They're a lot more lightweight. They're pretty good at eliminating anything that's completely irrelevant to you, but they will let go anything that may be even slightly relevant. These are much faster and much cheaper to run, which means they can run it on much larger datasets. This results in a much smaller dataset that can then be passed into more complex models. In this diagram, we can see 2 steps, but they probably have a few more steps that are hidden in there that are working together in this multi-level machine learning scheme that, when put together, finds the most relevant candidates for you in a pretty optimized and cost efficient way. Once the home ranker has all those candidates, the home mixer, like we mentioned earlier with the timeline mixer, it does the same thing of mixing them up and then serving them back to the front end. I hope that kind of explains what this diagram here is trying to show. With that, now let's get back to our original diagram here that has both the current and the next gen system combined together. Now, in this diagram, we see some connections and some errors that didn't exist in either of those diagrams, like these. The timeline mixer, that is the current or the existing system, is talking to this next gen home ranker, and also the home mixer is talking to the older timeline services. Why is that the case? I'm not really sure. It might be some sort of a strangler pattern migration strategy where they are using the home mixer or the next gen system for some of the features while still using the current system for the other features, and they're working together. It might also be that these services are talking to both the new and the old system and then comparing the results to figure out if the new system has any improvements or not. Now, most of that is just speculation. If I'm wrong about anything, again, let me know in the comments and subscribe while you're there. So that is what's happening when you first log into Twitter. What can we learn out of this though? There are 3 things really. The first thing, microservices.
We can call Papaya and MBS to get that user ID and turn it into a user session token. We can validate those with Omnop, and then, once we have that, we can finally pull the user's info down from Raccoon.
This is the video that a lot of people referenced when Elon first made this tweet, and for good reason. It's very easy to mock these complex microservice style architectures into something that people are making it overly complicated and it's really hard to make small changes. But this is the reality. If the Twitter system didn't look like this, it would very quickly implode and just collapse in on itself. Not computational wise, but more organizational wise. These architectures are not about trying to organize software. They're a lot more about how to organize the people that work on these systems. And these are the architectures that help a company like Twitter or any company of that scale still stay operational and not overload people or teams with too much work. Microservices is a reality. And if you're working on any kind of a project that has incredible scale, you are going to need it eventually. Second thing, the title to this video is a little clickbaity, I know, but it's really impossible to represent any sort of an architecture in a single diagram. And it's not just for Twitter. Even at relatively small scales, you will find it incredibly difficult or close to impossible to have your entire software architecture depicted in a single diagram, or maybe even 2 diagrams. You can try to do it, but it's going to be really unhelpful. Imagine if you have a survey with 10 questions and it receives 1,000 responses, or maybe let's go with 500. It doesn't have to be 1,000. Now, yeah, you can put all that data in just a spreadsheet. It would have 500 rows, it would have 10 columns. But how helpful is that data just on its own? Not much. You cannot make sense of a lot of that data. To do that, you have to ask really specific questions about that survey. And those questions have to relate to just 2 or 3 of the individual data elements that are in your entire survey. And those have to be measurable or something that you can calculate, something you can count. When you do that, you can create a much smaller set of data, which you can also visualize in some charts or graphs. And that's how you get real insight into that data. Just looking at the spreadsheet will not do that. Similarly, you can try your best to fit your entire software architecture in one diagram. It's going to be nearly impossible to do. And even if you do it, the end product is going to be very, very useless. So instead, you have to ask specific questions like, what happens when I first visit twitter.com? How does the system render my homepage? And this is the kind of answer that you get. This is how you get real insight into architecture. This is a very small subset of the entire architecture of Twitter. And even then, this is a simplification of the first call graph. This diagram here only shows tier 1 and tier 2 services. There are no tier 3 services in sight, even though there's probably a lot of them that are hooked up to each of these boxes here. This also doesn't give us too much insight into what are the technologies that are used by these services. All we have are GraphQL, Strato, and Thrift. We can make inferences that if this one arrow here is Thrift, we are pretty sure that most of these other arrows are Thrift as well. But again, that's not depicted in this diagram. You have to make that assumption. So the second learning is that to make sense of software architecture, you have to ask very specific questions and get very specific results and insights. Third piece of learning is a concept that I'll cover in a dedicated video. Here we see that Twitter is using at least 4 different kinds of databases. A lot of people might look at this and say, why not SQL? That's because SQL or SQL databases are general purpose databases. They're good at everything, but they're not super good at any one thing. There are a lot of limits to SQL databases when it comes to scaling and performance, and you're going to hit those limits pretty soon. And at the scale of something like Twitter, they hit those limits like a decade ago. If they continued using SQL databases, they would not have existed beyond 2013. So to squeeze out performance and scalability out of your databases, you have to kind of give up a lot of developer experience and ease of use that SQL databases give you. And you have to go for these hyper specialized databases that are really good at doing one thing and really bad at doing everything. And then what you end up doing is that you have a bunch of these databases that are all really good at the thing that they do, and you have to figure out how to combine them into a meaningful experience. For example, Manhattan probably has no relations. You can just dump a bunch of information in there about your tweets, about messages, about users. And then you would use a graph database to establish the connections between the people and between interactions. And then you would have to combine those two to come up with a meaningful experience for your system. Now, again, this is a topic I'll dive a lot more into. It's in a dedicated video. But those are really the 3 learnings that I have out of this. First one, microservices are inevitable at large scale, and you really will end up needing them. Second, software architecture is not something that you can just draw on a diagram. You have to ask specific questions and get specific responses. And the third, hyper specialized databases are how you achieve scale, not SQL. I hope that video was somewhat useful to you. Let me know down in the comments if there was anything that I misrepresented about the Twitter architecture here. Obviously, I don't have too much information here. If you're wondering how I got a lot of this information about Twitter's internal infrastructure or how they do things, well, it's pretty straightforward. They literally talk about how they're doing everything at Twitter in their blog. Again, the title to this video is a little clickbaity. Nothing about Twitter's architecture is leaked in this tweet. There's a lot more information on how Twitter maintains this infrastructure or how they make their decisions, really everything about their engineering that you can find on this blog here. And I'll have it down in the description if you want to see it. But this is where most of my information that I mentioned in this video comes from. The diagram just helped put a bunch of things together and answer the questions of how they work together to achieve value. But this is really where a lot of their technical information exists. It is just a gold mine of information. But there are still a lot of things that are not on this blog that I mentioned that I don't know much about. If you happen to know about it, hit me up on Twitter. And while you're there, follow me on Twitter as well. I'm kind of close to hitting 2,000 followers on Twitter, and I'll probably pass 2,000 subscribers on YouTube here soon. So make sure you scroll down and hit that subscribe button and the like button as well.